Hope everyone's having a good Arbitrum day. Thanks so much for having me to the Arbitrum team. I'm Matt. I'm from Caldera. We're a rollups as a service company. I'm here to talk about Arbitrum orbit chains, why you might consider building an orbit chain, the kind of motivations behind them, and how Caldera can help. I'm Matt, founder of Caldera, caldera.xyz. We are a rollups as a service company, part of this great wave of companies that's under this term RaaS. With Caldera, we're the easiest way to launch a dedicated rollup for your application, project, or ecosystem. In another sense, we're also an infrastructure layer for modular chains. We help deploy all sorts of other infrastructure to make these application chains viable. And we're also a white glove service. So we work really, really closely with the teams that we partner with to help them go from ideation, having an idea of an application, a set of requirements, all the way to building the app rollup that they really need in order to make their application as successful as possible. So I've split up this talk into 3 parts. The first of which is just going to talk through the history of Ethereum, of L2s, and hopefully give you guys a good intuition about why L3s might make sense for you. Then I'll go into specific features that you can build on an L3, and then briefly touch upon how Caldera can be useful. So in the beginning, there was Ethereum. Vitalik made Ethereum, and Ethereum was good. I think nowadays it might be a little easy to discount how important Ethereum was. But back then, prior to this whole idea of smart contracts or like a Turing-complete blockchain platform, blockchains were effectively just a way for cryptocurrencies to exist as a store of value and maybe optimistically payment rails. And so we got Ethereum, we got this idea of, smart contracts actually being able to move into production out of theory land. And that really enabled the blockchain to be thought of more of a platform for computation and for application development versus a store of value or, payment rails. But we have a major problem. Ethereum is slow. I've added a photo of the Altair 8800 to this slide because the Ethereum virtual machine on Ethereum mainnet can process about as many instructions per second in its quote unquote CPU as the Altair 8800. It's about 0.2 million instructions per second if you're interested. The worst thing about Ethereum, unlike an old school personal computer like this, of course, is that on this computer you're effectively running a single process for your user, game, whatever, text processing, etc. While on Ethereum you might have tens of thousands, hundreds of thousands, millions of applications, aka smart contracts, that are all fighting for resources on one chain. And so that leads to Ethereum being expensive, especially during a bull market. You guys are all crypto native. You probably know this intuitively. But when things get really congested and demand for block space is really high, it's not atypical for, in US dollar terms, for transactions to get to $50 per transaction, $100 per transaction. And that's really not tenable for most applications. And then one last thing to mention about Ethereum, which I think is often underappreciated, is that it's effectively ossified, or it's in the process of ossification, especially post the merge, where Ethereum is not meant to be a move fast and break things piece of software. It's meant to be this conservatively designed base layer where you can kind of trust that the behavior of the chain is the same from day to day. And so that's a really desirable property for a base layer, but it also means that if you're building an application on the blockchain, you can't really expect things to change that much, right? Ethereum is not going to get 100x faster on the base layer overnight. Any change needs to go through revision after revision, go through a committee, etc. And that's actually the desired property of the chain. And so because of all of these things, come 2018, 2019, 2020, people started to say, we need to scale Ethereum. We need to find some way to make Ethereum faster and optimally in a way that's Ethereum aligned. So we got, side chains, Polygon, Avalanche, right, Binance Chain to some extent. And those did scale the blockchain ecosystem in total. And it also, scaled the EVM's network effects, but it didn't scale Ethereum proper. And so the solution that all of us in the industry, I can't take credit, but the industry more broadly came up to was rollups, right? So the idea was faster, cheaper Ethereum secured by Ethereum, and the goal was Ethereum equivalence. So take Arbitrum, for example. You have strong EVM equivalence. It even uses Geth, the effectively canonical Go Ethereum client under the hood, and it even uses ETH as the gas token. So if you're a user or an application developer and you're building an application on Ethereum, you can be fairly confident that if you deploy it to Arbitrum, it'll behave as you expect. You're not going to run into any massive issues with compatibility. And also that Arbitrum itself is probably unlikely to make major breaking changes that make it difficult for your application to run. And so this is generally a very good thing. Of course, it's highly intentional, and it makes sense for like general purpose layer 2s to do this. So this is taken directly from Arbitrum's documentation page. It's designed to be compatible and consistent with Ethereum as much as possible. And that makes sense for most users. On some level, like the rest is history. Arbitrum 1 is the most successful L2 right now. According to L2 Beat, a little under 6 billion TVL. And that's because this model works for all sorts of different applications. However, that kind of opens up the question, what if we want to do something else, right? What if there's something, where we don't necessarily want the default behavior of Ethereum? And we'll get into all of the potential options here a little bit later. But more broadly, what if we want to make modifications to the chain in a way that helps support our app? So traditionally, the answer to something like this is to build a sidechain, build completely outside of the Ethereum paradigm, the Ethereum ecosystem, and use something like Cosmos SDK or potentially Substrate, something else that's similar. This is not a talk hating on the Cosmos SDK. It's super customizable. It's a great piece of software. It's a really great framework for building chains, but it requires a ton of code to use. It's super in-depth. It requires expertise that most blockchain application teams don't have. Strictly, basically, separate expertise from that needed to build a smart contract or like an app UI or a typical blockchain app. There also is a major requirement after you develop your chain to bootstrap infrastructure. So even just like validator sets and sequencers, et cetera, if you're building on the Cosmos SDK, you need to figure out some way to incentivize people to do that. There have been various estimations on how much that costs, just like on the monetary perspective. When you need to create a token, you need to inflate the token, you need to incentivize validators. I've seen the number put at 10 million. There are probably different people who might dispute that number, but oftentimes it's a lot. And also, building with the Cosmos SDK is not fast. And it's something that typically teams who decide to do this, they want to build their own blockchain. They don't back into the decision to launch a chain with the Cosmos SDK because they're building an application and they really need it. They are blockchain engineers. They want to build a really great blockchain. And so they decide to use the Cosmos SDK. But it doesn't make a ton of sense if you're building an amazing DeFi protocol or an on-chain game, or you're trying to build like an ecosystem hub chain for you to try to reinvent the wheel and develop everything from scratch. And so you might have heard about the modular paradigm. Effectively, what that is like separating all the layers of a blockchain. But even outside the world of modular blockchains, you effectively have these 4 layers. You have like execution, settlement, consensus, and data availability. And for non-modular blockchains, for monolithic blockchains, these might all be contained in the same part. You might have, you could say on some level, a consensus algorithm like Tendermint. If you plug it into the Cosmos SDK, it might cover the bottom 3 layers there. But it's kind of inherent in all blockchains to have these pieces. And so that kind of begs the question, if you're building your own chain, or you might want to build your own chain, which of these pieces are you actually modifying? And the truth is, like, you are probably modifying the execution. That's where all the fun happens. That's the virtual machine, how gas is processed, chain parameters, block times, et cetera, right? Maybe you want to do permissioning or whitelisting or native account abstraction. That all happens at the execution layer. And you might want to do some modification at the data availability layer just to explore that trade-off space and, potentially save some costs. What you're really not looking to modify are the settlement and consensus layers. And you see this, even with alt layer 1 chains, there's been consensus around using something like Tendermint, delegated proof of stake, similar algorithms, just because like there really isn't a huge point for most teams that are building like applications like application innovative L1s, L2s, and L3s to reinvent the wheel when it comes to settlement and consensus. And so this kind of leads to, a claim where if settlement and consensus are effectively implementation details and can be abstracted away, then it kind of makes sense for you to be doing these things as a rollup, right? If you just want to modify the execution layer, you might as well build within the Ethereum ecosystem, have native trust minimized bridging to Ethereum, and deploy this under the auspices and under the umbrella of the entire Ethereum community, rather than effectively create an Ethereum competitor. And this is especially true if your goal is not to build the chain in the first place. You just need to build a chain to make your app work. And so that brings us to the Orbit chain paradigm, right? Where we have Ethereum, the layer one, then we have Arbitrum, which is Ethereum equivalent and follows the Ethereum development roadmap pretty closely when it comes to the virtual machine. But now we have Orbit chains, which are instances of Arbitrum that we can deploy, where we can go hog wild and make the modifications we want and really experiment and do some crazy shit, that helps enable really cool applications. And so hopefully this sounds great, but you might be wondering what you can actually do. I wanted to give a brief overview of the possibilities of building a dedicated chain for your app and what that might mean. So the first order thing might be performance. You get dedicated TPS, effectively a dedicated lane on the highway just for your application. This allows you to de-risk from transaction fee spikes on other chains, other general purpose chains. It means that you're not going to be crowded out of accessing block space if some other application gets popular, which has been a major issue on some general purpose chains in the past, not Arbitrum, thankfully, but I won't say the names of them, but you can go Google and find examples of that. As well, you might be able to get lower fees. Part of that is because you're doing an L3, so you save a little bit of cost when it comes to the settlement costs because you're now posting data to an L2 rather than an L1. But more importantly, you can play around with how data availability is used on the rollup, and that generally accounts for most of the costs of running a rollup. So you can use a construction sort of like what Arbitrum Nova did, use any trust, or you can explore the trade-off space in between with Celestia, EigenDA, that sort of thing, and find the trade-offs that make sense to you with regards to security and decentralization and fees. The last thing I'll mention, it doesn't get mentioned a lot, is latency. For a rollup where right now the paradigm is centralized sequencers, latency to the actual rollup sequencer is a really big deal when it comes to the user experience that some users might have. And so certain applications, especially latency sensitive ones like gaming, potentially social, you might eventually see those applications shard themselves across multiple chains and direct users to the chains that are the lowest latency for them. And we have precedents for this in the Web 2 world with games like League of Legends or World of Warcraft, where there might be a North American server, European server, Chinese server, Japanese server, etc. You could effectively do the same thing with a blockchain, which might be interesting for like fully on-chain games or just like radical, interesting applications that might need ultra low latency. As well, there's customization. At the first level, this might include merging in EIPs that you might need. We recently did a project with a team that needed 2537 BLS curve operations just for like signature aggregation and verification. So we're able to merge that into the rollup, deploy it as its own chain, and enable them to do something that previously they weren't really able to do on the blockchain. There are tons of examples of this. Another one that might be interesting is 5988, which is the Poseidon hash function. This is like a ZK-friendly hash function that a lot of ZK applications use. And so if you're looking to develop a chain that supports those types of applications and makes it easier for those applications to be built, that might be something that's interesting to you. There's also, on some level, additional value capture you can do, especially in the bear market. I think a lot of teams are looking to, paths to revenue. And running your own chain gives you several such paths. You might want to add utility to your governance token or your utility token by allowing it to be used to pay for fees. You could also just collect sequencer fees, just like what Arbitrum or Optimism does themselves. Or you could even play around with ways to auction off MEV or run MEV tooling yourselves and either distribute that back to users or retain some as profits, or figure out just new novel economic models for monetizing MEV and your position as the owner or the runner, the sequencer of this chain to order blocks. There's also Alt DA, which I mentioned, any trust, or you could potentially tap into like Celestia, EigenDA, Avail, etc. for lower costs. Another thing I wanted to mention was like custom precompiles. This is effectively like a superset of the EIPs, but you could drop down into Go or Rust or Wasm or some other language and make it easy for, do some of your development in those languages, especially the like cryptographic functions, anything that requires a lot of like iterations or a lot of computation. You could add those into the EVM as custom precompiles, make it easy for them to be called effectively as smart contracts by other developers, and provide cool new features that the EVM doesn't natively support. And if you eventually extend that as far as possible, you could eventually get diverse virtual machines. So one of the interesting things that I don't think a lot of people realize about orbit chains or about optimistic rollups in general is that when you're doing the fraud proofs, they're being done on Wasm or MIPS or some other, effectively assembly language. And so what that means is like, although these chains right now are EVM equivalent, they don't need to be. And you could effectively compile Solana or Move or some other virtual machine down, make it fraud provable, and then run it as a rollup still within the Ethereum ecosystem. Of course, this is very far away. We don't ourselves support this use case, but we expect more people to be experimenting with this sort of stuff pretty soon. And the last thing I'll mention is that orbit chains or app rollups in general, they're dedicated, but they're not isolated. You have a hub and spoke model with Ethereum at the center, then Arbitrum, and then all of these other chains. And you get some really nice properties with that. You can settle on top of Nitro or Nova for way lower settlement costs. And you also get trust minimized bridging with Arbitrum, and therefore eventually the L1, for free by building on top of them. So hopefully that's gotten some of you motivated to think more about the app chain or the app rollup paradigm. And wanted to share a little bit about how Caldera might fit in. So we're aiming to be the easiest way for people to launch Arbitrum orbit chains. This is not ready yet. It's coming out later this month, but we're going to have a no-code UI that allows you to make a new deployment. It's going to be under 10 minutes to launch, and we're going to include all the infra. That's both the sequencer node itself, archive nodes like the core blockchain tech, but also things that make the chain viable, things like third-party bridges, block explorers, indexers, that sort of thing. We see ourselves there being kind of three pillars to our offering. We offer reliable sequencer hosting. It's often more of a headache than you would expect to run sequencers in a reliable way. And so we want to be the one-stop shop for teams that are thinking about app chains to come to us and offload that terrible headache rather than trying to take it on themselves. We're also constantly working on additional infra, whether that's looping in infrastructure partners like third-party bridges, third-party indexers, that sort of thing, or building tooling in-house to support app chain use cases. And as well, we offer dedicated support. We're really close with the teams we work with. We've even, in the past, we've merged in EIPs, we've written some custom precompiles, we've even done a little bit of smart contract development just to bridge the gap for some of the folks we work with. And so our mission is to make the app chain or the app rollup thesis more accessible. And part of that involves us, putting in some elbow grease and making sure that gets done. And so we're happy to do that as well. I wanted to leave you all with this quote. It's from Vitalik all the way back in 2021. And it really predicted a lot of what we're seeing right now with the proliferation of tons of L2s and L3s on Ethereum, right? We're going to get a multi-rollup future for Ethereum and a multi-rollup on top of rollup on top of rollup future for Ethereum, which will bring the Cosmos multi-chain vision to Ethereum, but it'll be on top of Ethereum. You get base layer security, you'll use Ethereum or some other networks for DA, and it's almost a homecoming moment for a lot of app chains that were previously going to be built as separate chains, but can now be built on top of Ethereum in the Ethereum ecosystem. So that's it for my talk. You can find information up there. I'm always happy to talk about app chains. Feel free to reach out anytime and let us know how we can help you support with Arbitrum Orbit deployments. Thanks so much, guys.